So hello everyone. I'm so happy to be here along with my teammates Firdaws, Kawther, Ryan and Sumaya. My name is Bayan. I'm going to present NaviDot and our journey in developing the mobile app for the device within 3 months using Flutter. Let me first introduce how we learned about Flutter. So I was part of Google Developer Student Society at Concordia University, and they had a mentorship program where they offer mentorship for a mentor and a mentee. I was the mentee, and I asked for someone to help me with mobile app as a career path, and I was lucky enough to be paired up with Billy. I had a meeting with him, and he convinced me to use Flutter for our project. And then I really liked it, and I talked about it with my teammates, and we said, okay, let's do it. And we learned about it like in 2 weeks. Then we started implementing it. It was a fun journey, and he was very helpful. Let me also introduce what NaviDot. So we are an engineering student at Concordia, and in order to graduate, we need to work on a project for 8 months. NaviDot was our idea. It's a tool for blind and deaf-blind individuals. We offer them text-to-speech and text-to-braille printing device. We print the name of the places along the user's route in Braille. So for example, if the user is walking and there are pharmacies, banks, schools, the user can select the category of the places and we print it for them. We just wanted to give them the same experience as we have it, like sighted people. Now we will introduce what NaviDot consists of before we talk about the main idea of our mobile app. Thank you.
So good afternoon, everyone. So let me first start by starting by explaining what the project is about. So our project consists of a portable Braille printing device that has a dynamic Braille display that prints user surroundings in Braille. Then we also, using the same device, we also implemented a collision detection feature where we use the haptic feedback to actually notify users if there is any obstacle that is in the way of the user within it was within 15 centimeters. We also implement, the device has also a speaker that tells the user about their surroundings. For example, if you want to do the audio mode, because our device consisted of both the audio and the Braille output mode. We implemented also a you can't see it here on the picture, but we have 2 buttons, one for turning off and on the device, and the second one is for the emergency button that the user can actually use to trigger, to click it on 3 times and trigger an emergency call. And this will actually make an emergency call to the emergency contact of the user that is printed on that can be changed on the app. We also have an app, Flutter, a cross-platform app that allows the user to connect to the device via Bluetooth and also select their destination. In the future, we are thinking of implementing a feature that the user can select their destination, and this will actually give them the instructions, and they can know the step-by-step directions in order to move from point A to point B. This is in progress. This was not implemented in our project. We implemented the device preferences where the user can actually select the type of the output, for example, the audio and the Braille, and as well as the range and the category and the printing speed. For the range, as you may know, you can actually select up to 150 and 150 meter. So you can print everything that is within the 50 meter. If for example, you choose 50 meters, You can choose 100 meters to and then 150. For the category, we implemented the category feature that the user can select which type of place they want to know about their surroundings. For example, pharmacies, schools, cafes, and restaurants. For the printing speed, as you may know, someone who's very proficient in Braille, they don't know, they can't really read Braille as like compared to someone who's really proficient. So they can select either low, high, or medium. So these are the app features. So we have a dual functionality that has the audio and the Braille mode. A quick emergency dial that the user can actually select set the phone number of their emergency contact, and then they can actually, this will, when they click on the button from the device, they can trigger an emergency call. We also have a live location where the caregiver can actually have real-time live location of the user, so they can actually see where their user is actually located. We also have, as I mentioned in the previous slide, the category selection, where they can select banks, restaurants, or cafes that they can print along their way. We also have the device preferences and the Bluetooth connection, because we are pairing the app with the actual hardware, the actual device via Bluetooth, and the user location tracking. And my colleague here will be presenting the technologies used. Thank you.
So this is the type of, these are the technologies that we have used. We have decided to develop the application using Flutter because we want it to be a cross-platform application, both available on both Android and iOS. We're using Google Maps API. Because we're getting the user's data, and we're obtaining the long and lat of the user, and then this is how we're obtaining the user's surroundings. We're pairing our device with we're pairing our application with an Arduino, because the Arduino is used to control the actual device, and the LiDAR sensor is used to detect obstacles. This is the architecture design. We have the phone. From the phone, this is the cross-platform application. We're sending the GPS location to the Google Maps API, and then we're retrieving data from the Google Maps API, and then we're using a database to store the user's information, such as the last visited place, the user's data, such as name and all these information, and then from the database we're sending the information to the phone, and then from the phone we're sending the information to the microcontroller, and then in the microcontroller, this is where we're actually printing our text from plain English to Braille. I'll let my colleagues here present the hardware part.
So after interviewing with our potential customers, we have designed our current device, NaviDot, out of the many notable features it has. So one of the three important features are the push buttons, LiDAR sensor, and Braille dots. So we have implemented the push buttons in a different way. So one, as Firdaws mentioned, we are using it to make an emergency distress call. The second push button we have in our device is to do the next line, to print the next set of datas. So for our device, we have a limitation to print 3 Braille dots. So we are using a next button push buttons to print the next set of datas. We also have LiDAR sensors integrated with the haptic feedback system. And what it does is that the more closer the user gets to an object, the intensity of the vibration increases, letting the user know that you're very close to someone in front of you. So here's our PCB. So it's a full 4-layer PCB, and the front layer has the circuitry for the sensors. We also have 2 different power regulators, 3 volts and 5 volts. We also have the back layer circuitry, which contains the Braille dots. So for Braille dots, we are using solenoids, and Ryan will be explaining more about this.
Yeah, so on the back side of the PCB, it consists of diodes, transistors, and resistors. And this is so that the microcontroller can control the Braille dots, like actuate them either up or down with the higher voltage of the battery. So can you click the next slide, please? So now I'll be talking about the mechanical design aspect of the project. So on the left side here, you can see the exploded view of the device. This was created using parametric 3D modeling software on Shape. With this, I used Onshape. And well, you could see the exploded view with all the slots for the solenoids to push the pins up. And these are like the pins on in the middle here. And this is the LiDAR sensor and the 2 push buttons. And this is the top view, so you can see the 3 Braille cells with the push buttons there. And then this is just a side view with the buttons here. So now I'll pass it on to Firdaws. Thank you.
So, okay. So now we'll be doing a live demo. We'll be showing a video for that presents the project that we've been working on. So this is a video that we presented during our poster presentation. Okay. So this is, okay, as you can actually see the video. Okay, so in our mobile app, we have a caregiver and a user. So the caregiver is the one who actually sets the type of categories that the user can choose. So this is the dashboard. This is the onboarding screen that you could actually see. So now we're creating an account as a caregiver. We're just signing up, just like the usual one, setting up the password. Okay, so this is the dashboard of the user. So now we're setting the caregiver information, the name, the phone number, and the email, the date of birth. We're choosing the country, the city. This is the feedback form where the caregiver can actually set their feedback. This is here we're printing the list of registered users. So the caregiver can actually, the caregiver, as you can see, if I go back here, so this is actually the list of the caregivers that are registered under the same user. So the caregiver can add as many users as they want to keep track of them. So using their username. So here, as you can see, we added Ryan here. So if they click on their name of each user, they can see the live location of each registered user. Okay. Okay. So now let's move to the actual user account. So here we're just signing up as a basic user, the deaf or deafblind individuals. We're just making the very basic registration process. Okay, so as you can see here, these are the device preferences, as I mentioned before. So we have the printing speed that could be low, medium, or high. So if you, for example, you wanna like the way that you print the Braille characters on the device, if you don't want to, because we implemented a 6 seconds delay on our device, so we're printing 3 characters at a time. So once you print the first 3 characters, you either wait for like 6 seconds, which is like the basic, the low printing speed, or if you are proficient enough, you can move to medium or high. For the radius, so we are setting a 50-meter radius to be as the default one, because if you set less than 50, you won't be seeing all the places that are within the range of 50 meter. For the output mode, the user can select either to be the Braille, which can be printed on the Braille device itself, or the audio, which is that uses text-to-speech feature. And then we decided also in the future we'll be implementing the Braille type. As you may know, there are two types of Braille. So there's grade 1 and grade 2. Grade 1 is actually like uses basic conversion from text, from like basic English characters to Braille text. And grade 2 uses abbreviations. So if you are also proficient enough, you can actually use grade 2. But like since we're in the first place, like in the first round of our project, we are printing only the name of places that the name of places that are in the surroundings of the users. So that's why we implemented only grade 1. Grade 2 can be useful if we are implementing the directions. So for example, you want to move from point A to point B. So we don't want to print like the whole step-by-step direction. We want to print the abbreviation. So for example, I don't know, like I'm just going to give you an example of the grade 2. Could can be, instead of just printing COULD, you would print CLD. So instead of printing like 5 characters or 6, you could just like print 3. Okay. So here, this is the main screen of our app. This is where everything happens. Okay. So here, the caregiver, what he or she will do is that they will select places category. So for example, I wanna give the experience to the user to know what are the pharmacies that are nearby. So they can select pharmacy, and then from here, they will see the Braille printing device. What it does is that it's going to actually print all the pharmacies that are within the 50 meters. So if I'm walking, I would see, let's take an example, the St. Catherine Street near Concordia, near EV building. So if I'm walking towards TD, so there will be pharmacy on my left, and this is the only thing that will be printed on the Braille printing device. If I walk more, like I would see Jean Couture, will be next to my right. If I select the school, I would see Concordia on my left, and what is it? There's also the continuing education college there. And for the cafes, there is Van Hout. Van Hout will be printed on my left, and the other cafe's second cup would be on my right. Okay, so this is the emergency contact page where the caregiver can set their phone number, so any emergency contact phone number. So from here, this will actually be used from using the emergency button. So when the user will click 3 times on the emergency button, it will trigger a call, and this call will be will just tell the emergency contact number that like something happened to the user. As here you can see, we're just setting the phone number. And then here, this is where we will be pairing the app with the device. We're just making the usual. Okay. This was the settings page, where you can edit the profile, change the password, or activate, deactivate the notifications part, the updates, and setting up the language and the country. Okay, now we're just selecting any destination. Okay, so we could actually see it here. So, yeah, we're just choosing another one too, Loyola campus too, right? And here on the user dashboard, you will see the last 3 places that the user has been to. So this is the device that we implemented. So as you can actually see, it's a portable Braille printing device that could be worn on the belt. So here we have the LiDAR sensor. This, what it does is that, like, as the user is walking, it will just vibrate, and the intention of the vibrations will change upon, like, based on how far you are from the obstacle. So if you're really close to any obstacle, the vibrations rate will increase. As you can see here, these three here are the Braille cells. So initially what it does is that, like, when the caregiver will select the category, for example, the pharmacies, you will see pharmaprix. So the way that it is actually printed, you will see the first three characters, and then after that you're done reading the first three characters, we either have like a delay of 6 seconds or a next button that you can actually click on it, and it will print this the second set of three characters. Okay, so here we have a live like a video. So the button that you could actually see here, this is the emergency button that I talked to you guys. And then here, this is the next button. That is actually when clicked, you can move to the second set of three characters. Yeah. So I don't know if you can see it here, but like the small pops up, like they could see here. These are the Braille dots. And like based on the alphabet that we're printing, you could actually see. So the way it works is that Braille cells are, the way that Braille works is that each character has 6 dots, and there is actually, so for example, for A, you would see like 2 dots that are popping up, and then the rest is actually down, and so on and so forth. B is also this, has a different conversion. We do support numbers, and in order to print a number, you have to actually print a dash so that you can tell your user that there's a set of numbers that you can actually start reading. As you can see here, if you just like hover over the character, like the Braille cell, you could know which letter you're printing. And as you can see here, we're moving to the next set of characters if we don't want to wait for 6 seconds. So yeah, we're done with our demo. So my colleague will present the challenges that we faced during our implementation of the project. Thank you, everyone.
So during the development of our project, we have faced a list of challenges. As my colleague have mentioned, we're linking our application with a Bluetooth, with a device. It's done through Bluetooth. So one main challenge is that we had to deal with unstable Bluetooth connection because we wanted our Bluetooth to use low energy. So we had to look through documentation, and we had to look to find out how the Bluetooth connection is done. Also, one other challenge is few documentation. I don't know if you are aware of, but compared to Android Studio, Flutter has few documentation. Because for Android Studio, for example, if you want to search how to implement something, or it tells you the steps one by one. But for Flutter, since it's a new technology, we're starting to see tutorials and documentation on the internet now, but not in details compared to Android. So we had to deal with it. Also, one main challenge is getting the user's location, because I don't know if you know it or not, but Google Maps doesn't only rely on the phone's GPS. It relies on other technologies to get the user's location. So to get the user's exact location, the phone's GPS is only 80% accurate. The others, Google Maps has to use other technologies. Also, the way we're determining the left and right, we're using a compass, and the phone's compass is not really accurate. So, like, the user has to hold their phone like this to tell what's on their left and what's on their right. This is a list of the packages that we have used. We have the lot and lang that we have used to handle geographical coordinates. The Bluetooth Low Energy, designed for short-range communication, optimized for low energy consumption, since we wanted our device to not consume a lot of power. We want it to have an autonomy of 3 to 5 hours. Also, we want it to transmit small packets of data. The Flutter TTS, since our device supports both modes, so audio and speed and Braille. So it integrates text-to-speech functionality and allows various customization options, such as voice output, changing the pitch, the accent, the language, etc. Lastly, we have the Google Maps API. We have used it to display the maps, add markers, customize map styling, and implement gestures such as zooming in and out. Thank you. If you have any questions, we're open.
Now, yeah.
Okay.
The Flutter Maps API used to be web only. Did that change recently?
Yeah, it supports both web and mobile versions.
And do you know why you're not allowed to get very accurate information from GPS and the approximate location? It's due to military restrictions for missiles.
So the reason why you can't have the 100% accuracy for the GPS location, it's because it uses the GNSS data, and like you have to be a professional to know how to manage this type of data. So there are like some mobile apps, like Android apps, that can return this type of data. And like based on your preferences, on your usage, you can just like get the list of these data and then just like filter what you need and do a lot of work in order to get the accurate positions.
It's just a comment, but I've implemented satellite acquisition software, and if you get lower than 20 meters, the US military will come to you and say you're not allowed to publish your hardware.
Yeah, and also like if I want to add also something to that, like I don't know if because on iOS and on Android it's very different. So even if you're not moving, you still have your function will be triggered. So even if there's like a very, very small change, it will just tell you that, like, let's say you're just holding the phone. Like only changing the direction of the phone will trigger the function. So it was kind of hard to us to actually get the 100% accuracy, or like even get like a 60 or 70% accuracy, and get these data and then just like manage them and determine what's on the left and then on the right, because that was the purpose of our project.
Because the military drones do get an accuracy within 2 meters when they're moving, because they use their own acquisition.
Yeah,
but as hardware implementers for commercial, you're not allowed to go within 20 meters. Otherwise, you break laws concerning military-grade hardware. Otherwise, there are certain sets of restrictions. You're not allowed for commercial application to go lower than a certain acquisition limit.
Yeah, I didn't know that. That's thank you. That's a good information to get.
Hi, did you get a chance to test this with any actually blind users to get their feedback?
So since it was a school project, we were not allowed to test it on real users because it involves a lot of paperwork and like back and forth between the departments. Yeah, so we only had the chance to like just have real real meetings with them, just to see, just to get their feedback and their output, but not testing on real users.
Good evening. Thank you for the presentation. That was great. It's a wholesome project, really, to be able to help disability. My question was more on the hardware part, more on the design. What motivated you to just display 3 characters at a time? Why not more? Yeah, that's my need.
Okay, I'll just let the hardware team to answer this.
Sure.
Yeah, so well, we use like solenoids, like electromagnetic actuators to put the pins up and down, and well, like refreshable Braille displays that currently exist use like piezoelectric technology, which is like really expensive, and like solenoids are very cheap and easier to manufacture. So like one of the main issues is that blind and deafblind individuals, well, they cannot afford these newer like $3,000 devices. So this tries to eliminate this. But you know, the issues with the electromagnetic technology that we used is power consumption, because you know, it's literally like a wire that's wrapped around, and it consumes a lot of current when you actuate the pin. So this is like one problem that we had. But yeah, like the solenoids themselves are pretty big. So with the 3 Braille cells, there's 18 solenoids that you need, and they're pretty big. So we can only stick with 3, and also that's pretty much why we chose 3. But in the future, we want to like make the device smaller, because right now it's also big, and solenoids, like I said, they're also big like this way, tall. So we're going to try to find like better solutions, but we wanted to keep the device cheap. So yeah.
So in terms of the width of the device,
yeah,
it's because the pin in itself is actually huge, right? It's pretty large. Correct.
The pin itself, like these?
No, the whole
like the solenoid
mechanism.
Yeah, exactly. This is
okay,
it.
but what explains the size in terms of height?
The height?
Yeah.
Well, the solenoid itself. Can you go back a slide? It looks kind of like this, and well, this is the height part. Like this is the top, right? That's the part that was pointing up. Well, this part is also kind of big, so.
Okay, so we're talking about something that is about like
rectangular.
3 centimeters.
I think it's like, yeah, like 3 centimeter, maybe like 20 millimeters and 30 millimeters.
Oh, it's bigger than I thought it was. All right, thank you.
No problem.
Okay, I'm going to be quick. Thank you for the presentation. My question was about your implementation of Bluetooth. I'm curious to know why you chose that. Would have there been another like alternative that would be more accurate, like I don't know, like an analog kind of plug? Do you understand my question?
Yeah, so basically we had the choice between Bluetooth and Wi-Fi for the connection with the device, like pairing the device with the app. So Wi-Fi consumes a lot of power compared to Bluetooth. So Bluetooth, we're using BLE, Bluetooth Low Energy. Yeah, so it consumes like it was in terms of battery consumption and yeah. Like if we used Wi-Fi, I don't think that the device would have lasted for more than an hour or so. Yeah, but like compared to Bluetooth, with Bluetooth we have like 3 hours or so of autonomy. Yeah.
Thank you.
No worries. You're welcome.
Thank you very much.